This is lesson 8.6, factoring special cases. Now this is only going to be helpful if you actually worked on the special cases in a previous lesson. So some people choose to look past the special cases and just work them out like they've worked every other problem, which is fine, but I still want to show you how these special cases work. So set up your paper for Cornell notes. This is your learning target, to factor perfect square trinomials and the difference of two perfect squares. Hit the pause button when you're ready to go. We'll move on. Okay, so recall that we learned some special cases when you're multiplying binomials. And the special cases, in this case, a perfect square, 2x plus 3 squared. Remember that really means 2x plus 3 times 2x plus 3. And if you remember, the special case was take the first term and square it. Take the second term and square it. And then to find the middle term, you multiply the two things together and double it. Double times 2x times 3. So this special case becomes 4x squared, 9, and the middle becomes 12x. The same was true when you have a subtraction, 4x minus 5, and it's squared. You're going to square the first term, square the last term, multiply the two together and double it. So this one becomes 16x squared. The last term is plus 25, and the middle term is minus 40x. And what you notice about these is when it's plus, all of them are plus. When this is plus, all of these are plus. And when this is minus, the last term is still positive. It's the second term that's minus. That's the special case where you have two binomials multiplied where it's a perfect square. The other special case was when you have the exact same numbers, but one is minus and one is plus. You find the answer simply by squaring the first term, squaring the second term, and subtracting the two. This is called the difference of two perfect squares. Difference because it's subtraction. Two perfect squares because when you square a number, you get a perfect square. So 9x squared is 81x squared, minus 6 squared is 36. That's review of the special cases. All you're going to do today is work backwards. You're going to take this special case and work backwards into two binomials, and this special case and work backwards into two binomials, and this special case and work backwards into two binomials. So it's supposed to be really quick, so I'm going to move a little quicker. If you start to get lost, just hit the pause button and you can slow me down. Here it is. The first one is y squared minus 16y plus 64. This is a special case. So you're going to factor by taking the first term and getting rid of the squared, and taking the first term and taking the square root of it. Square root of 64 is 8. And because you've got a minus in here, it's minus. That's the answer. Now how did I know that? I know that because the square root of 64 is 8, and 8 times y is 8y, double is 16y. Now again, as I said at the beginning, if you don't recognize the special cases right off and you want to multiply, or excuse me, if you want to factor it using the tic-tac-toe method, that's okay. But the more you recognize special cases, the easier they become and the quicker you can get through the problems. Here's the next one. 9q squared plus 12q plus 4. If I take the square root of the first term, I get 3q. And if I take the square root of the last term, I get 2. And if I multiply 3q times 2, that's 6q, doubled is 12q. This is a special case. Because both of them are plus, I'm going to add the two together and square it. Number 3. Now what you notice in this problem is there's no middle term there's no p term, and this has to be the difference between two perfect squares. P squared is a perfect square, 36 is a perfect square. So the answer ends up being, take the square root of the first term, square root of the second term, make 1 plus and 1 minus. P plus 6, P minus 6 equals P squared minus 36. Now, I'm going to go ahead and stop and let you try these three problems on your own. Notice there's an example of each type that we've looked at, one that has a subtraction, one that's all plus, and one that's a difference of two perfect squares. Try these on your paper, hit the pause button, and when you're ready to check your answers, hit play again. Okay, the first problem. Now, this is a lesson about special cases, so it's kind of obvious that they're all going to be a special case and they're all going to work out nice and neat. But if you had a test question and you didn't know if this was a special case or not, here's how you check. Take the first term and take the square root of the first term and you get 9r. Square root of 81 is 9, square root of r squared is r. Take the square root of the second term and get 5. Now, to know whether or not this is a special case, you should be able to square this 9r and get 81, and square this 5 and get 25, and then multiply 9r times 5 to get 45r, and then double it. If 2 times 45r equals the middle term, which it does, it equals 90, then you know you have a special case. And because there's a subtraction here, this middle has to be minus, and that binomial is being squared. And that's the answer. Look at the second one. Again, this is a lesson on special cases, so this most likely is going to be a special case. But just to check, I'm going to take the square root of the first term, which is k, square root of the second term, which is 6, multiply k times 6 to get 6k, double it, and it gives me 12k. This is a special case. Both of them are plus, so I put a plus here, and I square it. The last one. If there is no middle term, no h term or no x term, just an h squared and a number, then that's a good indication that it might be a special case. And if it's subtraction, that's another indication it might be a special case. To check whether it is, if the first term is a perfect square and if the second term is a perfect square, then you know it's going to be a special case. And to find the answer, you take the square root of 9h squared, and that gives you 3h. So your first term is 3h. You take the square root of 64, and that's 8. Now, because this special case is the difference between two perfect squares, you have to have this one with minus, and the same exact numbers with plus, and that's it. That's your answer.